Okay, nomenclature of aldehydes and ketones. And we're going to start by taking a look at a carbonyl and a carboxyl group. And a carbonyl group is when we have a carbon with a double bond to oxygen like this. And we find carbonyl groups in many functional groups. Carbonyl groups are found in aldehydes, they're found in ketones, carboxylic acids, esters, amides, anhydrides, acid chlorides, etc. But in this chapter, we're going to focus on aldehydes and ketones mainly, and we're also going to take a look at a carboxyl group as well. And carboxyl group is a group where we have a carbonyl group, but there's a hydroxyl, an OH group attached on one side. And a carboxyl group is found in a carboxylic acid. So whenever we find this functional group, we have a carboxylic acid. For example, acetic acid would be a carboxylic acid. And it says here that many of the functional groups at the center of focus in this chapter play important roles in biochemistry, and biochemistry is going to be discussed in chapters 11 through 15. Now, like I said, a carbonyl group, which is when we have a carbon with a double bond to oxygen like this. Carbonyl groups are found in what? They're found in aldehydes and ketones, as well as other functional groups, but we're going to focus on aldehydes and ketones here. So when a carbonyl carbon is bound or bonded to at least one hydrogen atom, the compound is an aldehyde. So if we have at least one hydrogen like this, then it is an aldehyde. Okay, an aldehyde if you have at least one hydrogen on one side of the carbonyl. And you can see that shown right here. A compound that contains the group, the group with the general formula that looks like this is an aldehyde. Okay, and the condensed form of an aldehyde is written like this, RCHO. So when you see this RCHO, you know that it's actually referring to this, which is an aldehyde. Now, a ketone, on the other hand, if we replace both sides of the carbonyl with carbon-based groups, I'll just put R here for carbon-based groups. Okay, in that case, we have a ketone. So ketone, keep in mind it is not ketone, okay? That is not correct, okay? It's Ketone, so I'll just erase all that here. But a ketone is a compound that contains the ketone functional group shown here with the general formula. And we can write the condensed formula of a ketone like this, where we put RC and then we put the O in brackets. And that O in brackets here, that denotes that it is a carbonyl like this. I know I use a green pen, so hopefully you can see that, but that's what that O in brackets denotes. And you can see some ball and stick diagrams here of two very famous aldehydes, or an aldehyde and a ketone, both of which are famous. So the simplest possible aldehyde that we can have is formaldehyde, which is used as a preservative for biological samples sometimes. And then next to it, we have acetone, which is nail polish remover. And so formaldehyde is the simplest aldehyde we can possibly have. Why? Because the carbonyl is flanked by two hydrogens, right? The simplest element that we can have, right? One proton and one electron. And then acetone is a ketone, but our carbonyl is flanked by two CH3 or two methyl groups, which is the simplest possible alkyl group that we can have. So these are just ball and stick diagrams of formaldehyde, an aldehyde, and acetone, a ketone, respectively. And again, formaldehyde is the simplest aldehyde we could have, and acetone is the simplest possible ketone that we could have. Now, here are some more common aldehydes and ketones. So it says here that several aldehydes and ketones, in addition to formaldehyde and acetone, are well known by their common names. Notice that aldehyde and ketone common names have distinctive aldehyde or "-one" endings. So if it's an aldehyde, it ends in aldehyde. And if it's a ketone, it ends in "-one." And much like other functional groups, the more complex aldehydes and ketones are named systematically using the rules as denoted by the IUPAC, right? The International Union of Pure and Applied Chemistry. And here are some famous, or I keep saying famous, here are some common aldehydes and ketones. So first we'll take a look at aldehydes. and there's three that they put here. The first one, the systematic name or the IUPAC name would be methanal, right? Meth for one carbon. So instead of methane, we have methanal. But the common name is formaldehyde. If we were to have four carbons, it would be not butane, but butanal. And the common name for that can be kind of confusing for students, but you go from butanal to butyraldehyde, right? They sound kind of similar in a way. Then we have benzaldehyde, and its common name is also benzaldehyde. You can see here that formaldehyde is actually, if its boiling point is -21, that would mean that formaldehyde is actually a gas at room temperature. Now you might be thinking, well, what about the formaldehyde that's used to preserve samples in a biology lab? I thought that was a liquid. Well, that is actually a solution of formaldehyde gas in water. Okay, so that's actually called formalin, but we call it formaldehyde. Then we have butanal, which has a boiling point of 76 degrees Celsius. And so it is a liquid. And then we see benzaldehyde, which has a boiling point of 178 degrees Celsius. So it has a much higher boiling point than methanal and butanal. Then if we look at the ketones that are shown here, so if we look at the ketones, we've got propanone and cyclohexanone. So propanone is also known by its common name, which is acetone, which is a liquid at room temperature. So acetone, nail polish remover, is a liquid at room temperature. And then we have cyclohexanone next to it, right? You can see the parent has one, two, three, four, five, six carbons in a ring, so cyclohexane. And then we add the ketone, so that's where we get the name cyclohexanone. And the common name is also cyclohexanone. Now, what are the rules that we use when we're applying the rules that are used by the International Union of Pure and Applied Chemistry for naming aldehydes and ketones? Well, the first thing we want to do is we want to find the longest carbon chain that contains the carbonyl group. Or in other words, we want to find the longest chain that contains our functional group. And then we want to number that longest chain in such a way that we give the lowest possible number to the carbonyl carbon. Now, in an aldehyde, the carbonyl carbon is always at the end of the chain, and so it's always designated as carbon number one. The second step is that we name the longest chain containing that carbonyl carbon using the IUPAC system. The longest chain that includes the carbonyl group is given the name of the corresponding alkane, but we replace the E with al for aldehydes, and we replace the E with one for ketones. So if you have something like butane, if it was an aldehyde, it would be butanal, and then if it was a ketone, it would be butanone. If you have pentane and you convert it into an aldehyde, it would be pentanal, and if it was a ketone, it would be pentanone. Next, we locate the position of the carbonyl by the number of the carbon atom to which the double bonded oxygen is attached. We locate and name any groups that are attached to that parent chain. And then we're going to combine the name and the location of the other groups, the carbonyl location and the longest chain into the final name. All right, let's take a look at example 10.1. The common name for the two carbon aldehyde shown in part A is acetaldehyde. And acetaldehyde is a toxic substance produced when alcohol or ethanol, so the alcohol would be ethanol, is broken down in the liver. And acetaldehyde is what is largely responsible for the feeling that you experience when you have a hangover, as you can see this person is having here. Anyhow, it says name the following aldehyde and ketones according to the IUPAC system. Okay, so the first one, they told us that the common name is acetaldehyde, okay? But there are only two carbons in this compound, one, two. And we know that if we have a two carbon alkane, the name is ethane. And so what we do is we drop off the E and we replace it with al for an aldehyde. And so the IUPAC name or the systematic name is ethanal. Now the next one, you can see that we have a total of one, two, three, four, five carbons in our main chain. We see that the carbonyl carbon is at carbon number three. So we replace the suffix from pentane which would be a 5-carbon alkane, to -one, so pentanone. And then we have to provide a number for where the carbonyl carbon is. And so this would be 3-pentanone. Now the last one has 6 carbons in a ring. So if we number those, we want to give the carbonyl carbon number 1. Then you can see that we have a methyl group on this ring, this cyclohexane ring, and so we want to give this the lowest possible number. So 2, 3, 5, 6. So keep in mind this is a cyclohexanone. And so the methyl group is on carbon 2, so we would call it 2-methyl 2-methyl cyclohexanone, like that. There we go. Now, if you had gone the opposite way, if you had started here 1, 2, 3, 4, 5, 6, that would be incorrect because then your methyl group would have number 6 here, and we want the lowest possible number for our methyl group. And so the compounds are ethanal, 3-pentanone, and 2-methyl cyclohexanone. Several naturally occurring aldehydes and ketones have very fragrant odors and are used in flavorings and perfumes. A number of naturally occurring aldehydes and ketones play important roles within living systems too. For example, progesterone and testosterone, female and male sex hormones, both just have ketones in them. You can see in progesterone, the ketone is found right here. And in testosterone, you can see the ketone is here. Now, we also have other functional groups in these compounds. In progesterone, we have an alkene here, and we have a ketone here. And in testosterone, we have an alkene here, and we have an alcohol here. And in this graph on the bottom right, we can see the sex hormone production in men and women. We have the average hormone production in percentage on the y-axis, and we have the age on the x-axis here. And you can see that testosterone levels for men peak at around 20 years of age, whereas for women, the estrogen levels peak in the late 30s. And you can see here that menopause occurs between 40 to 60 years here as estrogen levels decrease. And you can see that the male testosterone levels decrease going to past 80 years old. Carbonyl groups from aldehydes and ketones are also found in the open chain configuration of numerous carbohydrates, including glucose, which is an aldehyde. So you can see here in glucose, we have our aldehyde, and fructose. And you can see here in fructose, we have a carbonyl that's flanked by 2 carbons, and thus it is a ketone. Glucose is the major energy source in living systems and is combined with fructose and sucrose, which is the sugar that's found in sugarcane.